Now see, some theorems are left. We are proving theorem 1 and 2. Theorem 1 is that Euclid's division algorithm. That is theorem 1. Fundamental theorem of arithmetic. That we call it as theorem 2. Now we are doing theorem number 3. What is theorem number 3, you know? Let P be a prime number. You are given one prime number P. Okay? If P divides A square, then prove that P divides A, where A is positive integers. This is your theorem number 3. How do I prove? For proving this theorem, I let A can be, A is any positive integer, so A can be factorized as, suppose A can be factorized as A is P1 into P2 dash 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 into Pn. Suppose there are n prime factors for A. Some factors can repeat also, okay? But P1, P2, Pn are n prime factors, where P1, P2 up to Pn are prime factors, okay? Not necessarily distinct, okay? There can be repetition of same prime factors also, I don't mind. Now therefore, how can I write A square? A square is P1 into P2 dash 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 into Pn. Again you multiplied P1 into P2 dash 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 into Pn. Okay? So now I can say, now if P is any prime factors, okay? P divides A square. Then by fundamental theorem of arithmetic, fundamental theorem of arithmetic, what can you say? By fundamental theorem of arithmetic, what can you say? P must be one of the prime factor of A square. P must be is one of the factor of prime factors of P must be one of the prime factors of A square. A square has n prime factors. That is, P can be P1 or P2 dash 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 or Pn. P can be P1 or P2 or dash 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 Pn. And you know, by uniqueness of fundamental theorem, what can I say that? Suppose A is equal to also P1 into P2 into Pn. Clear? See, P is any one of P1, P2, Pn, and P divides A square. So A is also P1, P2, Pn. So P1 is any one of P1, P2, Pn. So I can say P divides A also. If P divides A square, then P also divides A. This theorem I am using for proving many other results. Okay, you can see. This theorem, I told you in the very beginning, that for proving irrationalities, we are using fundamental theorem of arithmetic. So theorem 4 is prove that, and in that I can use theorem 3 also. Prove that root 2 is irrational. Prove that root 2 is irrational. We applied here method of contradiction. How do I prove this? Here we applied here methods of contradiction. Do you know what we mean by method of contradiction? किसी छोटे बच्चे को हम बोलेंगे कि वो चीज ले आ, तो वो नहीं ले आएगा, मगर हम बोलेंगे मत ला, तो बोलते मैं लाऊंगा. सो जो प्रूव करना है उससे उल्टा हम एज्यूम करेंगे और फिर go on simplifying, go on applying my knowledge, and last में I will get contradiction. So due to that contradiction I can say my supposition is wrong. आपको प्रूव करना है रूट 2 इज इरेशनल. मैं एज्यूम करूंगी, लेट अस एज्यूम दैट, जो प्रूव करना है उससे उल्टा एज्यूम करने का. एज्यूम दैट रूट 2 इज रैशनल नंबर. जो प्रूव करना है उससे उल्टा मैंने एज्यूम किया. ओके, आई एज्यूम रूट 2 इज अ रैशनल नंबर. फिर आई गो ऑन अप्लाइंग सम स्टेप्स and last में I will get something very odd which contradict my given data or it contradicts some fact. Therefore, our supposition is wrong. So what we assume is wrong. So we assume root 2 is a rational number. So what is it? It is wrong. So what is root 2? Irrational. There are two possibilities. Either number is rational or irrational. When it is not a rational, it is irrational. Now I start the proof. Let us assume that root 2 is a rational number. Therefore, I can write root 2 can be expressed as P by Q, where P and Q are integers. And they are co-prime. That is, P and Q have common factor 1, that do not have a common factor other than 1, then I can say that they are co-prime. And here I can say Q is not 0. PQ belongs to I. But Q is not 0. That is definition of a rational number. Okay. I assume that root 2 is rational. At the same time, I assume that root 2 can be expressed as P by Q, where P and Q are integer, Q is not 0, and P and Q are co-prime. मतलब HCF of both P and Q is 1. मतलब your P by Q is in a simplified form or reduced form. Now, if I cross multiplied, I will get root 2Q is P, right? I am making square on both sides, so it is 2Q square is equal to P square. Clear? So, what does it imply? My P square is divisible by 2. So, I can say 2 divides P square. When 2 divides P square, by theorem number 3, I can say 2 divides P. Clear? When P divides A square, then P divides A. So, here A की जगह P square है. Okay? A की जगह P है और P की जगह 2 है. 2 divides P square. Therefore, 2 divides P by theorem number 3. Clear? Clear? So, this statement will be given as number 1. Now, 2 divides P. So, I can write P is 2C or 2K. Implies P की वैल्यू मैं इधर रख दूं 2q square, 2q square is p square में. If I put p is 2c, then p square is 4c square. So I will get 2q square is 4c square. That implies 2c square is q square. Again I can say 2 divides q square. Clear? That implied 2 divides q. I give this as number 2. So what can you say? By 1 and 2, common factor of p and q have 2. P and q have 2 as common factor. Clear? My p and q have 2 as common factor, but this contradicts our fact. But this contradicts our assumption. This contradicts the fact that, what fact we assume? Fact that p and q are co-prime. When p and q are co-prime, then common factor should not be 2. So this contradicts the fact that p and q are co-prime. Therefore, our assumption is wrong. Now do you understand what do you mean by contradiction method? Therefore, root 2 is an irrational number. Clear? Clear? Now, similarly, we can prove root 3 is an irrational number. फर्क क्या आएगा प्रूफ में? Can you imagine? खाली 2 divides p square and 2 divides p and 2 divides q की जगह 3 divides p and 3 divides q आएगा. So SCF of p and q or a and b will be 3. Suppose you want to prove root 5 is an irrational number. Then in proof will be same. Only फर्क क्या आएगा? फर्क क्या आएगा? Instead of 2 divides p and 2 divides q, we are going to get 5 divides p and 5 divides q. So SCF of p and q is 5, which contradicts our fact that p and q are co-prime. Suppose root 7 is given. Suppose root anything, root 7, root 11, root 13, anything you can prove. Okay? Here instead of 2, root 3 है तो 3 is a factor, common factor of p and q. Root 5 है तो 5 is a common factor of p and q. Contradiction में आएगा. 7 है तो 7 is a common factor of p and q. Okay? So all this result we can prove by contradiction method. Method is very similar. Suppose you want to prove instead of single irrational number. Suppose there is combination of two number. One is rational, one is irrational, or both are irrational. Addition of rational and irrational, or addition of two irrational. Any combination is given. Suppose you are asked to prove that 5 minus root 3 is irrational number. Then this also we can prove by contradiction method. But here, one thing you remember. Here root 3 is an irrational number we are accepting as a fact. Okay? See, let us assume that five minus root 3 is a rational number, suppose. So naturally, I can say 5 minus root 3 can be written as a by b. क्लियर? p by q की जगह मैंने इधर a by b लिया. b is not 0 and a and b are integer but they are co-prime. मतलब they are in a this rational number is in a reduced form. So if I change this side, I can get root 3. Root 3 I am taking on that side. A by b I bring on this side. 5 minus a by b. Clear? So it implies root 3 is 5b minus a cross multiplication. Now you know very well a and b are integer. So naturally I can say 5b minus a upon b. b is not 0 दिया है. Is a rational number. What is definition of rational number? What is definition of rational number? It is of the form ratio of two integer but denominator is not 0. Clear? So it is ratio of two integer, denominator is not 0. So it is a rational number. Right? Therefore, my root 3 is also a rational number. Clear? Because root 3 is 5b minus a upon b. So, अगर 5b minus a upon b rational है, तो root 3 is also rational. But this contradicts the fact that root 3 is irrational number. We know the definition of irrational number. Right? Irrational number are under root of p where p is not a perfect square. Right? Every square root of p where p is not a perfect square are irrational. So I am using the definition here, not the proof. But this contradicts the fact that root 3 is an irrational number. Therefore, our assumption is wrong. Is wrong. Our assumption is 5 minus root 3 is rational. That is wrong. Therefore, I can say 5 minus root 3 is an irrational number. Okay? Clear? Clear? Is it not interesting? This method of contradiction is a very interesting method. You can prove anything by contradiction method. पहले assume करो कि जो तुम प्रूव करना चाहते हो वो गलत है और नीचे मैथ्स का मॉडल ले आओ, कुछ नॉन मैथमेटिकल चीज ले आओ. So it contradict the fact और it contradict our assumption. कुछ भी को contradict, कोई भी चीज जो सही है उसको contradict करेगा अपना assumption. मतलब our assumption is wrong. Our starting is wrong. Clear?